Hi everyone, welcome back to our YouTube channel Sid Education. In our today's video, we are going to work on an example using bubble sort. So let's get started. Let me have a array with the element 80, 40, 20, 100 and 60. Now I need to sort this array using bubble sort. If you remember in our previous video, I was talking about some of the key points where I have discussed that bubble sort is based on brute force technique. And brute force nothing, it's a problem solving method that involves trying every possible solution until get the correct one. So same thing if you apply to the bubble sort, that is you keep trying, you keep checking your adjacent element, and in case your adjacent element is for example 80 and 40, I know 40 is less, so it should come here. So I'll keep trying this, I'll keep swapping so that I will bubble up. Bubble up in the sense I'll make the largest element to its right position. Alright, and if you remember, I told you that if I have n elements, how many iterations I need? N minus 1 iterations. So let's trace those iterations in this example, and then we are going formally see the code of this bubble sort algorithm. So let's get started. So what happens with bubble sort? So I told you that n iterations. So let's check how many elements it has. 1, 2, 3, 4, 5. So it has 5 elements. So how many iterations we need? 4 iterations we need. So if I write iteration 1, so what happens in iteration 1? I am just repeating again what I have discussed in our previous video, that in bubble sort we compared the adjacent element of the list and exchange them, that is swap them if required repeatedly. That is, for example, 80, 40, 20, 100, 60. So first comparison you will made here. So I'll write comparison 1. You know that 40 is less than 80. The correct position of 40 should be above 80, right? In sorted array, 40 should come before 80. That is, you need to swap. So once you swap, you get 40, you get 80, you get 20, you get 100, you get 60. So the agenda of this bubble sort is that we need to bubble up the largest element to the last position. So in iteration 1, this 100 should go to its correct position. Then in second largest element should go to the second largest position, right? So second comparison I will make from here to, oh my bad. So second comparison I will make from 80 to 20. So I figured out, yes, this is my comparison to 20 is less than 80. Therefore, I need a swap because 20 should come before 80. So 40, 20, 80, 100, 60. Then again, I'll make a third comparison with 80 and 100. So if you see 80 and 100, if I compare, I know 80 is less than 100. So it is at right position. I don't need to swap. Why I was swapping here? Because the element which was after 80 is less. And when you sort in an ascending order, 40 should come before 80. 20 should come before 80. But 80 should always come before 100. So this is right. So I will only compare, but I will not swap. Okay. So your thing remains same. Now what you will do? You will compare the last, that is 160. So what you will observe, what you have got, 40, 20, 80, 60, 100. So did you get the 100 to its right position? Right? So you will compare here, I'll write compare 4, 60 is less than 100 and then you will swap. So once you swap, you got 100 to its right position. This is what iteration 1. That is why I was telling that what we do, we keep comparing the adjacent item of the list. So now you need to understand that you need two loops. One for this thing, one pass, second pass, third pass, fourth pass. And second to go to iteration 1, iteration 2. Okay. So let's trace the second iteration. So what you have now, you have this, that is 40, 20, 80, 60, 100. Now you don't have to see this 100 because it's already sorted. Now your agenda is, you are in second iteration means you need to bubble up the second largest element to its right position. So let's get started. So you compare 40 with 20. So 40 with 20. So 20 is less. So you compare. Okay. Then what you need to use swap also. So it will come 20 will come here, 40 will come here, 80 will come here, 60 will come here, and 100 is already there. Then you compare 40 and 80, you see that it is right. So you just compare, you don't swap. So 20, 40, 80, 60, 100. Then you compare 80 and 60. So you figure it out, yes. You compare and 60 is less than 80. So you swap also. So 20, 40, 60 and 80. Now you stop here because you get the 80 to its right position. So 80 and 100 now sorted if I consider this way. Now why I'm writing that swap and comparison, because many a time question asks how many number of comparisons and number of swaps made during the algorithm, right? That is why. So if you see how many comparison we made in iteration 1, 2, 3 and 4. 4 comparison, how many swap? 1, 2, I think 3 swaps. Now in iteration 2, how many comparison we made? 1, 2 and 3. So 3 comparison, how many swap? 1 and 2. 2 swaps. Okay. So let's move to the third iteration. How many iteration we need to do? 4. Because we have 5 elements. So you take this as input, that is 20, 40, 60, 80, 100. And these are already sorted, so we need to work on this only. So 20 and 40, you just compare, they are at right position, right? 80, 100. Now then you compare 40 and 60, they are also at right position. See, that's why you should understand now that we are not stopping. If you see, these are sorted only, but we are not stopping our algorithm. The algorithm will keep its iterations, right? It means that when we are going to analyze the time complexity, we are not getting the reason when we have a worst or we have an average. We are not getting the luxury to stop the algorithm. Hence, the time complexity might be same for some cases that we are going to analyze and going to drive in our coming videos. But are you understanding those things? If you have seen our previous video, you will get the gist that when the average, the worst and the best case comes and there is a limitation, the time complexity varies. But here you see this is already sorted. If any algorithm which says that if you have already sorted, you stop here. So you don't have to go to iteration 3. But here we'll see that we are still going to iteration 4 as well. Okay, means we keep doing it. We don't see whether it's sorted or not. There is no way in the algorithm that to see or to check whether the array is sorted or not, right? So you just compare it. So it's already right position. So 20, 40, 60 comes at now the right position. So if I talk about how many comparisons you made 2 comparisons, and how many swaps? You made 0 swaps. Okay, now this becomes input for the iteration 20, 40, 60, 80, 100. So if you see now, this is already sorted. Now if you compare this with this, it is at right position. So you don't need to do anything. So ultimately all elements, so this all are at right position. You are left with one means it is already at the right position. That is your one comparison, 0 swap. So if I talk about how many total comparison we made 4 plus 3 plus 2 plus 1. That is 4 plus 3 plus 2 plus 1. And how many swaps we did? We did 0, 0, 2 plus 3. That is 2 plus 3. This is 10, this is 5. So this is how bubble sort algorithm works. If you like our video, please